And this is the time to do this integral by second method. Okay, because the method is quite long, so I use the two videos. Okay, the method one, you can go see it, in the link is below. Okay, I'm using second method now. The method is start with substitution. Let the x be cosine theta. So my I is equal to, this is changing, right? X sine theta, x equals 0. That means half pi. 1 equals 0, 1. Then this is equal to cosine theta and log cosine theta plus sine theta. And dx will be negative sine d theta. Okay, good. All right, then this is equal to this negative to switch the order. So now, okay, then becomes a tangent, right? Tangent theta times log sine theta plus cosine theta. Very good. And then I start the Feynman's trick. I create f of a is equal to 0 to half pi tangent theta times log sine theta plus a cosine theta d theta. All right. So my objective integral is when a equal to 1. So this is f of 1. That is my integral when a equal to 1. Right? Now, then I then I want to find f of 0 because it's useful later. F of 0 will be equal to this integral uh, tangent theta and log sine theta, right? d theta. Very good. Then I let y be cosine theta. Then this becomes well dy is what? Dy is equal to negative sine theta d theta. Is correct. And when theta equals 0 is 1. When theta equals to half pi is 0. And tangent is sine over cosine. Right? Log sine would be log square root 1 minus cosine theta square theta. Okay. And d theta Yeah, d theta, yeah. Now, sine theta d theta is a dy, negative. So I change it, switch the order. So negative is gone. It becomes dy over, it becomes a dy over 1. So this one is a dy over y, and then switch the integral limit. Okay. Then this becomes what? This becomes a half log 1 minus y squared. Very good. Good. We finished the conversion. Now, then what? Then we're using the series, log series. Log 1 plus x is equal to sigma n equal to 1 negative 1 to the n minus 1 x to the power n over n. Now, if you don't use n minus 1, then you put a negative outside. Negative 1 to the n, right? Outside is negative 1. But the same thing. Okay. So this is equal to 1 half integral and summation n equal to 1 to infinity. This one is using this, right? This one is equal to n is n y minus 1 to the n minus 1. This one is negative negative y squared, right? It's equal to negative y squared to the power n. Yeah, and dy. Good. Now let me work out a little bit for this part. Okay, the numerator is negative 1 to the this times negative y square n. This is rather complicated. Now this one is a negative 1 to the n times a negative 1 to the negative 1. Right? And this is a negative 1 to y square n. Yeah. So this one equal to negative 1 to the n times this is negative 1. This one is a negative 1 to the n and y to n. Yeah. So this one is equal to this is negative 1. This is the one. This one is positive 1. Huh? So it's negative 1. Yeah. This one is negative 1 to 2n. Is always positive. So negative 1. Yeah, that is the result of the numerator. So this one is equal to 1 half. Since this series is convergent between 0 and 1, therefore, okay, we can switch the operator, and then it becomes the integral 0 to 1 and n y. This is negative 1, negative Okay, good. See, that is this, right, the numerator. Okay, good. Now then, let me continue from here. Now we switch the operator, take negative outside, and n equal to 1 to infinity, integral 0 to 1. Well, n to n minus 1. Yeah. So this one is equal to negative half, and sigma and 1 to infinity. This integral is equal to n times 2n, right? Y to 2n, 0 to 1. Very good. All right. Then this is minus half sigma 2n squared. And this 1. Yeah. So this one is equal to negative half, negative quarter times this from 1 to infinity. So this is Basel problem, right? 24. Okay, that is my f of a 0. Okay, what are we looking for? We're looking for f of a 0. We're looking for f of 0. So, okay, so f of a 0 is equal to negative pi squared over 24. Okay, good. All right, what then? This is f of a. This is f of a 0. My I is equal to f of a 1. I need to find f of a f prime of a before find the f of a okay, the f of a is equal to, just let me recall, that is this is my f of a. Let me copy f of a. It's an integral tangent log sine x theta plus cosine theta d theta. This is the f of a. Okay, so my f prime of a is a partial derivative with respect to, this is a here. I forget. This is a here. There's a here. Okay. So this derivative would be equal to pi tangent theta. Log derivative will be this plus a cosine theta. The chain rule times this derivative with respect to a, that is cosine theta. Okay, this is 0 to pi, and this becomes a sine. This is sine theta plus a cosine theta. And I divided by sine everywhere. You get this. You get this is d theta. Right? This will be 1. This will be a times cotangent theta. Wow. Things are getting a little better. Yeah. Then what? Then I'll let the t be cotangent theta. This is t. And theta will be arc cotangent t. So this integral becomes 1 plus a t. Yeah, that's correct. And this will be, d theta will be d arc cotangent. This is equal to negative 1 plus t squared. Right? Yeah. And the boundary has been changed from 0 to half pi, become infinitive to 0. Yeah. Now then I use this negative to switch the order. So it becomes 0 to infinity. And dt and 1 plus at times 1 plus t squared. Very good. Well, then we're using partial fractions. This one equal to integral this plus this one 1 plus at 1 plus t squared. This will be this is a quadratic, so this is a t plus b. This is a linear, so c, right? dt. Yeah. Very good. Now I omitted the steps to determine ABC, right? This is not difficult. You know how to do it. A is equal to this. A 1 plus a square. B is equal to 1 a plus 1 a square. C is equal to a square 1 plus a square. All right, simply, to determining those coefficients. All right, then my integral becomes, what is that? F of a, right? F prime of a. This is f prime of a. It becomes this is a common factor, right? And let me write this one first. This one is integral from 0 to infinity. 1 plus t square. A is this, right? This has been taken out. So negative at. That is this. B is a 1. Okay, dt. That is this one. C plus, this has been taken out. This is a square integral, right? 1 plus 1 plus AT dt. Yeah, that's correct. Okay, good. This is a square. Now this can be done easily. This over this one, the integral is a negative a over 2 natural log 1 plus t squared. So that's for this integral. And 0 to infinity. 1 over that integral is arctangent. That's easy. This integral is natural plus a squared divided a and then log 1 plus at, right? From 0 to infinity. Wow. Okay. So this one is equal to, all right. Now this is easy. This is half pi. Let me put this one first. Then these two combined, this and that one, I put them together because this one is equal to negative t1 log 1 plus t squared from this one. And that one is from a to natural log 1 plus 8 squared. Okay, good. So this is 1 plus a squared upon. Now these two can be combined. This one is equal to plus a. A is common factor, right? Log, this is positive on top, 1 plus a t. This one is negative on bottom. Half becomes square root. Yeah, very good. Yeah, this is 1 square, half pi. Now, when t goes to infinity, I take this t out. So everything becomes I take t out. This becomes a log. This is half. Sorry, plus of a here, right? A it becomes a log a minus when is 0, then 0. Good. So my finally I have this. My f prime of a is 1 over a squared half pi plus a log a. This is my f prime of a. Okay, good. Now then I'm using Newton-Leibniz formula. F over 1 minus f over 0 is equal to the integral from 0 to 1 f prime of a dA, right? Yeah, that is a Newton's formula. Now, I want this because because of what? Because of my I is f of 1. And I have this one already. This one is this. I just need to find this. Then I find my objective I. Okay, this one is equal to integral. Well, okay. Let me consider this one. Okay. Consider this one only. This one is equal to 1 plus a squared over half plus a log a dA. Right? Yeah, for this one. The first part is easy. Half pi. This was arctangent. A1 from 0 to 1. That is the first one. The second one, a log a dA. Yeah. Okay. Now this one is easy. This is a quarter pi. This is becomes 8 pi. 8 pi square plus this log a dA. Now let me working out this integral. That is well. Well, how to I have this. Forget this one. Oh. Sorry, this has to be multiplying. So, okay, this one, a log a, 1 plus a squared. Okay, let me work on this one. Now, while I'm using power series, right? This is 0 to 1, a log a. This is a power series from 0 to infinity. This is negative 1 to the a squared. Right? This is power series, anyhow. Okay. This one is equal to switch the order of operator. This becomes negative 1 to the power of this. All right, negative 1 to the power n. And yeah. Yeah, that's right. This is a combined to this one. This is equal to log a and a to the 2n plus 1. Yeah, dA. I'm sorry, too many details. Sometimes I'm missing something easily. All right. Now here I'm using by parts. All right, this is negative 1 to the n. Here I'm using by parts. So this is log a. This is d a to the 2n plus 2, right? Over 2n plus 2. Yeah. So I can do by parts. This is 0. It's negative 1. Right? I take this out. Let me write again. Sigma 2n plus 2. I take this out. Yeah, then bypass du dv, right? So this is I forgot the integral 0 to 1. 0 to 1. I forgot the integral minus integral v du. V is this, du is this, 1 over. So it becomes a to the 2n minus plus 1 dA. Well, I hope you follow. Then sigma n 0 a. This could be written as this, right? Negative 1 to the power n. This one, when a equals 1, no problem, equals 0. When a equals 0, this is in negative infinity. This is 0. So this goes to 0 faster than this goes to infinity. Or use L'Hopital's rule. Use L'Hopital's rule. This is 0. And this integral is 2n plus 2, right? So end up with negative. This becomes 2n plus 1 square, right? Yeah. So it becomes this 4n plus 1 square. Yeah, very good. This is only just one term of this. So my f of a, let me organize again. We are working this one, right? So we added this one and this one. So f of a 1 minus f of a 0 is equal to now pi square over 8, right? Plus whatever we have done here. So plus, yeah, okay, good. Now f over 1, this one we have done already is equal to negative pi out squared over 24, right? We have done before. Now is equal to pi square over 8. For this one, I take 1/4 out, right? So this one is let me work out. This one is a this one is a 1 minus square, 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 square. Every even number square is negative. Order is positive. That is this one. So let me work out this. This is 1 minus plus 6, right? So this one is equal to, well, if everything is positive, it's a positive problem. And this, everything is positive, and to take away those even power, you take twice. Take one is not enough. You take twice of those even numbers square. Okay. So therefore, it becomes what? This minus 2, this is a 4, and pi square. Okay. So this is become this. So this becomes pi square over 8 plus 4 times pi square over 12. Finally, I find my I, which is f of 1, is equal to, this is negative, right? Negative pi square over 24 plus 8 pi, or 8 plus positive negative. It's a negative, huh? Yeah, remember it's negative? Yeah, where is it? It's a negative. It's a negative. It's a negative. So it's negative 48 pi square. I'm sorry, is that? So after calculation is equal pi square of 6. But anyhow, you can trace back, correct, well, correct if there are some errors, but negative. So everything should be okay. But it's quite complicated. But this is the second method. The first method I did on the other videos. You can go see it. The link is below. Thank you.